In this video I'm making a custom Damascus steel dial for a Rolex Submariner style build. It's a fully custom dial and I'll show you how I made it from scratch all the way through the complete assembly of the watch. The real challenge in this build, at least for me, isn't making the Damascus steel, but instead turning it into something precise enough to live inside a watch, hitting the correct dimension for both thickness and the overall dial layout. But the first step is forging the Damascus steel that will eventually become the dial. I'm not going to go into too much detail here because this part of the process is both the least complicated for me and not the main focus of this project. I've made Damascus steel many times before, so for this build, I just want to cover the main highlights and get straight into the parts where things get more critical. So I'm keeping things very simple. You just saw me clean up and cut the steel into thin strips. I don't need much material here, and working with thin strips lets me increase the layer count quickly without having to restack the billet multiple times. I'm using alternating layers of 15, N20 and K720 steel, starting with 26 layers, and to hold all those pieces in place I lay down a quick bead of MIG weld. Then the forging process itself is very straightforward. Plenty of heat and a bit of borax to act as a flux and help push out impurities during the forge weld. I start compressing the billet gently at first, just to set the welds, and after a few heats I take it under the press and really start moving material, and with an hydraulic press like this it doesn't take much time at all. Then off camera I cut the initial billet in half and restacked it, and this brings the layer count to around 50. From here it's just a matter of squishing the material down and drawing it out into a bar about 5mm thick. And even though we started with very little material, I ended up with enough length to get a few watch dials out of it, or potentially use it for other small projects. With the billet fully drawn out, I start pressing in a round indentation. This is a pattern known as Raindrop Damascus, and normally you do a lot more holes, either drilled or pressed, but for this application I only want one hole. That translates into a single round pattern, which I think could work well here since the final shape of the dial is, of course, circular. I'm using a series of ball peen hammers to press in the indentation, and no worries, the hammer I'm striking with is soft, so there's no risk of chipping. And just like that, the Damascus is done. From here we can move on to turning this rough material into an actual watch dial. And this is where the build starts to get more challenging. The goal now is to bring this small piece of Damascus down to roughly 4 to 5 tenths of a millimeters in thickness. And at that thickness, things get fragile very quickly. To get the level of precision I need here, I'm using a tool I made myself, a surface grinding attachment for my belt grinder, which is also a custom build I made a few years ago. I start by placing the billet on the magnet with the indented side facing down. This side will eventually be the back of the dial, so the first step is simply to clean it up, remove the scales and get this face perfectly flat. With that done, I flip it over, and now it's time to remove material until the indentation is completely gone and I'm left with a flat uniform surface. I take my time here, starting with a 60 grit belt and being careful not to overheat the material. After some time the piece is completely flat on both sides, but still a bit too thick. So now I need to grind it down about half of its current thickness, so I switch to a finer belt and start working toward the final thickness, attaching the material to the magnet with the dial face down, so I'm not removing any of the pattern. To reach the correct thickness, I use a simple trick. I place a sacrificial steel ruler against the magnet. This helps keep the piece from sliding, since at this thickness it doesn't stick well to the magnet anymore, and it also acts as a height reference. This ruler is roughly half millimeter thick, so once I just start grinding into it, I know I'm in the right range And as a visual guide, I grind until the markings on the ruler disappear, which puts me right between 0.4 and 0.5 millimeters. And just like that, I end up with an extremely thin piece of Damascus steel. I do a quick etch in ferric chloride just to see how the pattern turned out and decide where to position the dial for the most interesting result. And then we can move on to cutting out the actual shape of the dial. For this part of the build, there's one crucial tool that makes the entire project possible, and that's the F2 Ultra by X tool. It's a fiber laser, which means it's extremely precise and capable of cutting very small details, exactly what you need when you're making something like a watch dial. Now, hand cutting and drilling a watch dial like this is technically possible and has been done for a long time, but I don't have the precision equipment or the skill to manually work something like this down to about 0.2 of a millimeter. For me, that level of precision is impossible by hand, and this laser makes it achievable, and it does that pretty quickly too. Before we get into the laser cutting though, I want to quickly talk about the design. All the dimension and layout for the dial come from the technical schematics of the NH35 movement that I'll be using for the watch. It's a PDF with pretty much every measurement you could imagine, and using that as a reference, I designed my own dial in CAD. The only thing I had to measure manually was the hole size for the hour indicators, and other than that, it was a pretty straightforward process. And this simple design can be imported directly into the X-Tool software for engraving and cutting. The F2 Ultra has a 60 watt MOPA fiber laser, and I'm running it at around 70% power to avoid overheating the material. And to manage heat even further, I'm using a large aluminum block as a heat sink with thermal paste to transfer heat away from the dial during cutting. The dial is placed face down, and I mark the center on the back so I can align it precisely with the design. Once everything is set up, I can let the laser do its thing, and thanks to the power of the F2 Ultra, this process only takes about 15 minutes. And just like that, the dial is fully cut out and ready for finishing. So I hand sand the dial on a flat surface, working my way from 400 up to 5000 grits, and I hold the dial with a small magnet, and since the surface area is quite small, the finishing process is fairly quick. And instead of ferric chloride, I use a hyper-concentrated coffee etch, which helps improve the contrast between the dark and lighter layers of the Damascus. This isn't an aggressive etch, it's just enough to bring the pattern to life. You can see the contrast is high, while the surface is still polished and reflective. And now that the dial is finished, it's time for the most tedious part, installing the hour markers. These pieces are absolutely tiny, and I'm terrified of losing one as I don't have spares. But before installing them, I first attached the two dial feet on the back of the dial. Their position was marked by the fiber laser, and I glue them in place with the tiniest drop of CA glue. These need to be perfectly aligned since they position the dial relative to the movement, and any deviation would be visible in the date window. Finally, one by one, I place the hour indicators into their alignment holes and glue them from the back, again using minimal amount of glue so the face of the dial stays perfectly clean. And yes, this took a long time, but that's it, and here is the finished Damascus dial. Now I can place the dial over the movement and install the hands. First the hour hand, then the minute, and finally the second hand. And I went with a red second hand just to add a small touch of color, and here is the first time I get to see the movement running, which is always a cool moment. And once the hands are on, I insert the full movement assembly into the watch case. And at this point it's already looking really good. Before closing the case, I cut the stem to length and install it, along with a small gasket for the case back, and this should help with water resistance. With that in place, I screw down the case back and seal everything up. And here it is. I really like how it turned out. Everything lines up perfectly and the hands clear all the components and move freely. On the back you can see the balance spring in motion, which is always fascinating to watch. The very last step is installing the bracelet, which is quick and easy, and just like that the watch is 100% complete. And that's it. I'm really happy with how this turned out, and I think the single Raindrop Damascus pattern works very well on a round dial. One important thing to mention, if you haven't noticed already, is that this is not made with genuine Rolex parts. Those are simply way too expensive for a small hobby project like this, so the movement is a Seiko NH35 and the case, hands and our markers are all generic parts inspired by the Rolex Submariner design. They're easy to find and inexpensive as well. I really hope you enjoy this project. For me, it's a great meeting point between metalworking and watchmaking, which is something I've only picked up recently, but I really enjoy. And wearing something I made myself is always satisfying. As you saw, this project was made possible thanks to the F2 Ultra, so huge thanks to X-Tool for providing the machine. And if you're interested in learning more about the MOPA fiber laser, you'll find more information in the link in the video description. And hey, let me know what you think about the design choices. I'd be curious to hear your ideas for different Damascus patterns, and if you'd like to see more projects like this, definitely let me know. Thank you very much for watching, have a great day, and I'll see you soon in the next project.